Okay, fine. Let's take a look at this one then, because it's slightly different. It's the same idea though, it's the same idea. Okay, so what are we going to let u equal? Where's our substitution? The x squared minus 3, you happy? Okay, so u equals x squared minus 3. Let's do our differentiation now, okay? So what would du by dx equal? Be 2x now, okay? So it's slightly different to what we were looking at before, because now our derivative still has an x in it. It's not just a constant, okay? So what would dx be equal to? Can we do the rearranging? So dx by du, so the other way up, would be 1 over 2x, which means that dx must be 1 over 2x du. Happy with that substitution, that rearrangement? Now we do the substitution, okay? So we get the integral of, well, we haven't got rid of that 2x yet. We haven't got rid of that 2x. So we still got 2x, but then this is going to be u to the power of 4. U to the power of 4, okay? But our dx is going to be 1 over 2x with respect to u. Happy with that? Okay. And you're like, well, hang on a minute. Surely the whole point of integration by substitution is that we end up with a function purely in terms of the thing we're integrating with respect to. So we're integrating with respect to u, that's what du means, okay? And we've got a function in terms of u, but we've still got x's going on. But can you see it doesn't matter? Good, because you end up with 2x divided by 2x. They cancel. So the x's are gone, right, because of the substitution which we've made. So therefore, we get the integral of just u to the power 4 with respect to u. And that's easy because it's just a fifth of u to the power 5 plus c. Yeah? Which then means that u is just x squared minus 3, so therefore we just make our substitution. Is that okay? Good. Just very quickly then, let's have a look through this question. Okay? So similar kind of thing to what we were doing before with integration by substitution. However, now we've got limits. Now we've got limits. Now, I'll warn you, it doesn't matter how you do this. Okay? So there's two different approaches, and I'm going to show you both. Okay? And then you can decide which one's easier for you. Right? So we start off in exactly the same way as we did before. Right? So what we're going to let u equal?
2x plus 4.
Perfect. We're going to let u equal that function which is buried within it. Okay? Which then means that we differentiate this, du by dx. What do we get? 2. And then if we find dx, what's that equal to? Perfect. Half of that multiplied by du. Perfect. Okay, so then we just do our rearranging. Oh, sorry, we make our substitution. But what I'm going to do is I'm going to leave the limits off. I'm going to deal with the limits last. Does that make sense? Okay. I'm going to find the area function first, then I'm going to stick the limits in. Okay. So I'm going to say the integral of, well, this thing is now u. So u to the power 5. dx is just a half of du. So actually I could pull that half out the front. Okay, because it's not going to affect the integration. Okay. So let's find the area function. Well, you're happy this thing is just a half. That's going to be u to the power of negative 5 with respect to u. So it means I get half of, well, let's raise the power by 1 to become negative 4. Let's divide by that new power, plus c. Okay? Tidy it up slightly. I get negative 1/8 of u to the power of negative 4. So that's going to be 1 over u to the power 4 plus c. Okay? And then I make my substitution back again. So I got u equals 2x plus 4. So I get 2x plus 4 here to the power 4 plus c. Okay? So this here is my area function. So once I've found my area function, then I can reconsider my limits. Does that make sense? Okay? So here I can say, well, look, actually all I've got here is my area function, which is negative 1 over 8 times by 2x plus 4 to the power 4 plus c. Okay? Then I just consider my limits, which are between 0 and 2. And I just stick my limits in. Yeah, just exactly the same as I did before. Got my area function, stick my limits in. So I'm going to go negative 1 over 8, lots of 2 plus 4, all raised to the power 4, minus, same thing, but with 0 stuck in. So I get negative of a negative, which is a positive, yeah, of 1 over 8 lots of 2 lots of 0 plus 4 all raised to the power 4. Is that okay? Yeah, you clear why that becomes a positive? Because it's taking away a negative function. Yep. And then you just stick all that in your calculator and see what it comes out as. Okay. The other way, if I did want to think about the limits, I'd have to change them here. Does that make sense? So I know that these are really just x values, aren't they? So x equals and x equals 0 and x equals 2. When I'm down here, I'm talking about u. So I'm going to need to rearrange them. So I know that u is just 2 lots of my x value plus 4, right? So therefore, if I stick x equals 0 in here, I'm going to get u equals 4. And if I stick x equals 2 in here, what am I going to get? U equals
10.
Yeah.
No.
No.
8.
8. Yeah? And then, when I get here, I don't have to worry about converting back. I can just stick 4 in, and then 8 in, and then work out the area from there. Does that make sense? Yeah? So either I can do it as I would normally, without worrying about the limits until the very last point, or if I wanted to think about the limits, I could do it here. Okay? Personally, I think it's easier to do it at the end. Yeah? But if you wanted to do it there, that is also fine. Any questions? Okay, let's take a 10-minute break then.